Hello, everyone, and welcome to another episode of Hard Truths Podcast. I'm your host, Ashton Forbes. Today, I have a very special guest. Harvard astrophysicist Avi Loeb is with me today, and we're going to talk science and physics. Now, the reason why I'm so excited to talk to Avi Loeb is that he's not afraid to talk about topics that other academics won't broach, like aliens and UFOs. So today, we're going to talk about some amazing stuff. Avi, thank you very much for being with me today. How are you doing?
Thanks for inviting me. It's a great pleasure.
So just let's get started right away. I want to ask you about what I just mentioned. Is from my perspective on the outside looking in, it looks like academics are afraid to talk about some of these topics that I see you talking about all the time with podcasters, like can we communicate with aliens? What would other civilizations look like? And how would other civilizations use science and physics to get here? What is it about you that makes you different? And what do you think about your peers? And if do they judge you for that?
Well, it's just a matter of common sense. We exist on a rock that was left over from the formation of the sun, and we see similar rocks, Earth like planets, around the other sun like stars. And in fact, there are hundreds of billions of such systems based on the latest estimates within the Milky Way galaxy alone. And then there are a trillion galaxies in the universe. So thinking that we are unique and special and nothing like us exists is really very presumptuous, very arrogant. And as a matter of common sense, we should accept the possibility that there are many other kids in our cosmic neighborhood and they might be smarter than us. What could be more natural than that? So I'm just applying common sense. And to me, that is part of reality that we have to learn about. We see our house. It looks familiar, the solar system, the Earth moving around the sun. And then we see other houses, planets moving around other stars in our cosmic street. And the only question we have to ask is whether there are any residents in those houses. That's not such a difficult question to address with modern science, with the tools that we have. And so all I'm saying is forget about science fiction, about the lore that people without any substantiation bring up all kinds of stories that have no credibility. Forget about this. It's completely unrelated. There is a fundamental question whether we are not only away from any physical center of the universe, the way people thought before Copernicus, but perhaps we are not even at the intellectual center of the universe, and let's learn from others. Now, you may ask, why is this commonsensical view not dominant within the mainstream of the scientific community? And, that's one of these anomalies within academia that the culture is for people to show off that they are smarter than others, not to take any risks that may ruin their reputation, and not to interact with the public in a sincere fashion. Usually, the approach is to have press conferences in which you tell the public your results, like a teacher in a class. But that's not the way I see it. The public pays money through taxes to support science, and the public cares a lot about this particular question. So I think it's completely inappropriate of scientists to ignore this question and to have committees that are claiming that addressing this question is too risky and in fact may result in wasting taxpayers' money. I say the taxpayers want us to study it. We should attend to that. But I cannot hope to get funded by the standard committees that NASA or the National Science Foundation assemble because they're full of those traditional thinking and not no risk taking scientists. And I get all of my funding from private donations or donors.
So let me ask a devil's advocate thing, because I think that they would probably say, well, you can't go probably even close to the speed of light, and the nearest star is 4 light years away. And from their perspective, they would say also we can't achieve faster than light communication. So we're kind of just stuck out in the middle of nowhere and with no hope of ever getting to somebody. So how would you respond to that criticism that they would levy? And would you say that there might be another solution that we just haven't figured out?
Well, that's not factually true. So the thing is that Voyager, the spacecraft that we launched, will exit the Oort cloud of the solar system within 10,000 years. and we'll get to the opposite side of the Milky Way galaxy in 1 billion years. Okay, now most stars, like the sun in the Milky Way galaxy, formed billions of years before the sun. So if you imagine a copy of what we have here, just translated in time to an earlier time by a few billion years, then they could have reached us by now. Even their Voyager-like probes that move with the same technology, they are propelled by chemical rockets. Those would be able to reach us as long as their star was at least 1 billion years ahead of ours. And that basically tells you you don't need to travel, because there could be objects that arrive to our vicinity that spent recent billions of years to get here. So instead of us going to the neighbor's yard, we might as well check for any tennis balls that were thrown by the neighbor.
So you're expecting what Van Neuron, is that what it is? Van Neumann probes? Is that the theory that you're kind of throwing out there right
Not
now? Is that what
necessarily.
you're
I mean,
searching?
even space trash. If as long as the civilization, we are preoccupied. If you look at the news, we are preoccupied with problems on the surface of this rock, and we invest $2.4 trillion in military budgets, very often trying to kill others or preventing others from killing us. And most of the time, it's about territorial disputes or power struggles. But this is all on the surface of this rock. And in fact, there is much more real estate out there and in interstellar space. So this makes very little sense. And you could imagine that a civilization that is sufficiently advanced, that has a perspective about interstellar space, would actually launch equipment or actually even beings or systems with artificial intelligence away from their home planet. So this is really the key. It's not so much how long does the civilization last, but whether they escaped from that original habitat that they were born on. And if they did, you will just, even if the equipment that they launched is not functional anymore, the way Voyager will not be in 1 billion years, it will lose its functionality, it will still be space trash. And just like finding plastics in the ocean, keeps accumulating, the gravity of the Milky Way galaxy can keep those objects from escaping because they move at a speed that is 10 times too small. Unlike the speed of light that radio signals propagate. So the traditional approach was to wait for a phone call, but nobody may call you at the time that you're listening. And indeed, over the past 60 years, we haven't detected any clear signal. However, if you are searching for objects in your backyard or packages in your mailbox, those may have arrived a long time ago. The senders may be dead. Most of these may not be functioning, but you could distinguish them from natural objects like rocks, asteroids, comets, and so forth.
So I like that. I like the idea. I mean, you're looking under every stone, literally and figuratively, for possible signs of other beings or any ancient civilization.
Well, actually, I should say that within the orbit of the Earth around the Sun, there should be of the order of millions of objects that are meter in size from outside the solar system. We know that based on the frequency of interstellar meteors. These are objects colliding with Earth that arrive from outside the solar system. So we haven't really searched those millions of objects right now within the orbit of the Earth around the Sun. The Sun is significant because it acts like a lamppost that is illuminating. So it's just like looking for your keys under the lamppost on the street. It's much easier to find the keys. So I'm saying there are millions of possible keys, and all you need to do is sort out whether any of them appears to be technological in origin. And to do that, I mean, we can't, with the current telescopes, we can't really observe meter-sized objects from the reflection of sunlight. They are too faint. But I'm suggesting, with the investment of hundreds of millions of dollars or a few $1 billion, we can definitely study those. And nothing of that nature was actually done so far. And I actually, just a few weeks ago, I heard Peter Thiel, who, following the presidential election, he said, you should never bet against Elon Musk. And so the following day, I wrote an essay betting against Elon Musk because Elon said, well, we are probably alone in trying to motivate settling humans on Mars so that the human species will be a multiplanetary species. But I try to explain that, in fact, uh, you know, there are within the observable volume of the universe, there are 10 to the power 21 uh, Earth Sun systems. And we actually know that there is no cliff just beyond the cosmic horizon, that the conditions continue for at least 4,000 times farther away. So there are altogether 10 to the power 31 Earth Sun systems. And I'm willing to take a bet that we are not alone. Okay, and my bet is that I will put 1% of my net worth against 1% of Elon's net worth in a pool. We would dedicate that to the study of any evidence, as I mentioned, for example, studying all the interstellar objects in our vicinity. And then, if in 10 years we won't find the evidence, I will pay a second 1% of my net worth to him. Uh, so if you think about it, I mean, you might say that's a lot of money on his part, but it's actually just $4 billion. The Webb telescope was $10 billion. The Large Hadron Collider was $10 billion. For addressing a question as fundamental as that, it's not unusual to spend billions of dollars. In fact, the next observatory that the mainstream astronomy community wants to build would be the Habitable World Observatory, looking for gases like oxygen or methane in the atmospheres of planets as they transit the face of the star that hosts them. But that will be probably in the 2040s, and it's a huge amount of money, and it's not clear that we would learn whether microbes exist, because you can make those gases also by natural origins that have nothing to do with life, like geological processes. And what I'm saying is, with the investment of less money than that, but comparable, we can not only find evidence for life, but in fact, learn that there are technological civilizations in our cosmic neighborhood.
Yeah, and I think Musk says he hasn't seen evidence of aliens, which is a kind of a different claim than what you're putting out there, which is that just from a statistical odds perspective, there must be aliens out there.
Oh no, so I actually addressed his comment on that matter as well. He said that no object, and that's related to unidentified anomalous phenomena. He said no object collided with a communication satellite of Starlink. But I did a simple calculation. If you put a meter-sized object at the same altitude as the Starlink satellites, so you just put it there, the chance of it colliding with the Starlink satellite is once in 1,000 years.
So,
okay, so the fact that nothing collided with, I mean, Starlink satellites are not really built for the purpose of searching for objects near Earth. And I put it in the same altitude. It might be in very different altitudes than those satellites. So that's not evidence for it. I mean, it's just like saying the Starlink satellites did not detect the Higgs boson. Therefore, I have no evidence that the Higgs boson exists. Of course, you needed to build a machine, okay, within CERN that took decades to build, that cost $10 billion, that would look for the Higgs boson. You have to build equipment that is dedicated for the task. You can't just accidentally expect new knowledge to fall into your lap, because everything that falls into our lap is already known. You know, we see birds. We know about the moon. I mean, these are things we know about because they are easy. They are low-hanging fruit. We've been seeing them since we were born, and humans saw them for millions of years. However, if you want new knowledge, something that is not easy to get at, you need to put the effort and the money to do it.
yeah, I agree. And I think that, so I guess let me press you and Elon both at the same time. Now, I would say I would bet 1% of my net worth, and I would say that if we started searching with high frequency gravitational waves, we might find them. And the reason why I say this is that, maybe if alien civilization exists and they are much more advanced than we are on the time scale, then I think assuming that they're going to use communication methods that we use today is kind of egotistical in our perspective. Maybe we're looking at the problem all wrong. And maybe that's the reason why SETI hasn't been successful in finding messages and why we've been kind of naive.
Well, it depends what you call high frequency, because we do have the LIGO experiment that detects gravitational waves. So far, all the signals detected relate to black hole collisions within the observable universe. So what do you mean
But
by
those
high
are low
frequency?
frequency gravitational waves, at least as far as I've been made aware, that those are.
Okay, well, they're the highest that we can detect
Mhm.
from Earth, but there are lower frequency waves that the LISA experiment will try to detect within a decade or so. So actually, nobody is talking about higher frequency, although in principle, gravitational waves can go all the way, to gigahertz or higher frequencies that we have electromagnetic signals in. But to generate such waves requires a lot of mass moving very fast.
That's exactly what I'm getting at. Because at the end of the day, we're talking about, well, are we cavemen on this block? And if we are, if there are civilizations that are out there, why are we assuming that they're less advanced than we are? Well, they could be easily more advanced. And look at how far we've come in just 100 years. Imagine us in 1,000
Oh,
years.
sure, sure.
I don't think we're going to be riding around on SpaceX rockets. And so my question to you is, do you think, like Elon Musk said, we're going interplanetary on SpaceX rockets? I don't even trust a SpaceX rocket to take me to Mars, let alone to like Europa or another star system. What about you? Do you think that we're going to go with that, or do you think it's going to require new technology?
No, of course. I mean, we are just making the baby steps in moving away from our planet right now, in these decades. And obviously, as we develop better technologies, we would move faster and better. Okay. And
Mm-hmm.
so imagine sending a ship into the ocean, okay, that moves relatively slowly because it's propelled by wind. And then you develop a steamship that moves faster because it has its own propulsion. So obviously, you would uh, pass the past technologies as you move by them. So if you imagine a civilization developing on an exoplanet, at first you would see rockets that are rather primitive, the chemical rockets that we are using, coming out of the planet. Suppose you were looking at it. And then you would see more and more sophisticated means of propulsion coming out that move faster and basically reach the slower ones within a relatively short time and then go much farther. And so obviously the future would be far more
Mm-hmm.
impressive for us if we survive. That's the fundamental question. We discovered quantum mechanics just a century ago, and you may ask, how much longer do we have? And if we don't leave our planet, there could be lots of catastrophes that could destroy our technological. Some of them are self-inflicted, and in the form of AI or biological warfare or maybe nuclear weapons, and political instabilities could trigger catastrophes. And so it's important to have more than on that. I agree with Elon that it's important
Mm-hmm.
for us to venture outside of our planet. But the question is whether that will be taking the form of humans in space or maybe AI systems in space. That's to be seen. But one thing that is the reason for finding evidence for other civilizations that preceded us by
Mm-hmm.
billions of years is to see what they have done and get inspired by it, because it may give us new ideas. Now, the way I approach it is not to imagine what they are, to say, oh, they send gigahertz gravitational waves, therefore I will try to build a detector for gigahertz. No, the way to approach it is to use the best detectors we have in any possible way, whatever we have at our disposal, and look for things that are not familiar. Okay, so if we have infrared cameras, you look at the sky and you see, is everything in the form of birds, clouds, leaves, drones, balloons, airplanes, satellites, or is there something that is not familiar? And it's true in any domain. It could be the domain of gravitational waves as well. So the point is, just be curious enough that when you see a signal that is anomalous, you would entertain the possibility that it may be of technological origin from outside of the solar system. And that's really the block that keeps scientists away from this
Mm-hmm.
subject. It's not the lack of anomalies; it's sort of the distancing from the possibility that an object like Oumuamua that looked weird in all ways, that was different than any rock we have seen before. They would agree with that, that it's a rock of a type that we've never seen before. But they would say that it's a rock. That's it. And they would say the same about the Tesla Roadster car that Elon Musk launched in 2018. It's a rock of a type that we've never seen before. So my point is we should be open-minded that others are doing what we are doing. That's not very imaginative actually. And if you think about it, it shouldn't be controversial. So when Enrico Fermi said, "Where is
Yeah.
everybody?" he was not trying to seek evidence. He was just entertaining himself with this question during lunchtime. And, whenever you see a lonely person, they often ask, "Where is everybody?" And you tell them, "Look, don't think that you're so attractive, they will be next to you all the time. You need to be proactive. At the very least, look through the windows of your home to find a partner or go down the street and check." But you can't just argue, "I don't see them next to me," because this would have been a low hanging fruit. And obviously, they're not next to us because space is vast, time is measured in billions of years. So the chance of them being next to Enrico Fermi in Los Alamos in 1951 is minuscule. Why would exactly at that time, exactly at that location, there would be clear
So
evidence for them?
I want to dig into that more in just a sec, but before that, I want to get your opinion on something that I haven't heard you talk about much, which is what do you think about the UFO community? Because I haven't seen you interact much with like really any of them. And is there a reason for that, or do you avoid them for certain top reasons? Is it too sensationalist for you? Go ahead.
No, that's not true. I just don't interact with many people at all. I mean, I don't have any footprint on social media, okay? And I don't care how many likes I get. So I'm not running a popularity contest. If I were running for the presidency of the United
Mm.
States, obviously they would hear a lot from me, but I'm not. And I'm just trying to do my work, my contribution as a scientist to addressing this question that they care about. And so I'm trying to work rather than to talk. A lot of people talk. Okay, so you might say, "Well, that's great. Let's talk about this subject. Maybe it will bring disclosure." Well, the disclosure of what? We need to see the actual evidence. Okay, so either we see the evidence or you can just talk about it forever without making any progress. So my point is, if the government will not provide us with useful information on this issue, the sky is not classified, the oceans are not classified. I'm dedicating my time and effort to in leading the Galileo project that will uncover some evidence, direct evidence that will be shared with the public. And that's the only way for us to demonstrate that something, there is a neighbor in our cosmic street. And the Galileo project, we have a working observatory at Harvard University. We're currently assembling two others, one in Pennsylvania, another one in Nevada. They're fully funded. And just yesterday, I heard from someone who might be pitching significant funds for another observatory. So, these are at the level of millions of dollars investment just over the past 6 months, the kind of money I'm getting from donations. Now, there is also the expedition that, I led back in June 2023 to retrieve materials from the first interstellar meteor that was identified by US government satellites. And we went to the site in the Pacific Ocean near outside the territorial waters of Papua New Guinea. And we retrieved materials from the bottom of the ocean that is more than a mile deep and brought it for analysis in the laboratory of my colleague at Harvard, Stein Jacobson. And over the past year, we analyzed the materials. We found a fraction, 10% of those molten droplets that have a very unusual composition that seems to be consistent with an origin outside the solar system. What we want to do is go back to that site and find bigger pieces, bigger fragments, so that we can tell the nature of this object, whether it was a Voyager like or a Tesla like interstellar object, or just a rock from another star. And we have already we try to reserve a ship for August 2025. At the moment, we are waiting for funding. We need $6.5 million to do the job. We have an exceptional team that is ready to do it.
So let me jump in there because first of all, I have a question, burning question about the meteorite that you got out of the bottom of the ocean. How did you find that? Did the government just come to you and be like, hey, we've got some satellite imagery of this meteorite hitting the ocean. You want to go get it? Because it feels like a needle in the haystack situation, but somehow you came up with, real samples. So how?
Yeah. So the story started from me being interviewed on the radio back in January 2020 about another meteor that landed near Kamchatka. And just in preparing for that, I went online and I found this catalog that NASA has of hundreds of meteorites that were identified by the fireball that they created as a result of their friction with air. So they simply exploded, and there is an array of satellites that the U.S. government uses to detect the heat from launches of ballistic missiles around the globe. Yeah. So those satellites every now and then see the explosion resulting from the entry of an object from outer space that collides with Earth. And they decide it has nothing to do with national security, so they put it on a public site that NASA compiles, JPL, the Jet Propulsion Lab. And I became aware of it, so I told my student at the time, Amir Siraj, to let's go and search through this catalog and see if any of these objects was moving too fast to be bound by gravity to the sun. That will make it an interstellar object, an object that came from outside the solar system, because the sun's gravity cannot bind it. And we found one that was clearly an outlier from 2014, January 8th, 2014. And it was moving actually at 60 kilometers per second outside the solar system, faster than 95% of the stars in the vicinity of the sun. And it exploded very low in the atmosphere, 20 kilometers above the Pacific Ocean. So that meant that it had material strength that is tougher than all other meteors in the catalog, all hundreds of them. It was the toughest one that disintegrated, exploded only very low in the atmosphere at a very high speed. And so to me, I mean, and then I reached out to the US Space Command through the White House and got their confirmation that indeed they think the data is valid, and at the 99.999%, this object came from outside the solar system. So there is this memo that they wrote to NASA. So at that point, I decided to lead an expedition to the Pacific Ocean to search for the materials. Now, the location itself was specified in that catalog that NASA had. That's where they spotted the fireball. It's not a single point because the meteor is actually moving at a very high speed, 40 kilometers per second, very high speed. And so over the time of the explosion, it actually tracks, tens of kilometers. And so there is a line, or actually they defined a region that was about 10 kilometers by 10 kilometers where the brightest flare occurred. And we went there and we scanned that region. We went back and forth, like mowing the lawn, going, and we collected as much material as we could from the ocean floor. These were magnetic particles, altogether about 100 milligram, of magnetic particles that looked unusual. And then we analyzed them in the laboratory and found this unusual composition, chemical composition, that is very different. Some elements are up to 1,000 times more abundant than in the primitive materials that made the solar system. And these are elements like lanthanum, beryllium, uranium. So we call it Belau for beryllium, lanthanum, uranium, as a new type of composition.
So I want to just dig right into it. You know what? I'm going to try to solve the UFO phenomenon with Avi Loeb right here on the live stream. So let's just jump into the main question, the burning question. This is a UFO. Let's imagine it can be some ball of light. It can be a flying saucer, whatever. It's just hovering around. It's able to do this. It can even shoot away at high speeds. What is the energy source for this UFO that doesn't have any SpaceX rockets tied to it?
Well, I need to get data on it. So based on the way it moves, I would know how much power is required for it to operate this way because the acceleration reflects the force that is acting on it. We need also to know to have some estimate of the mass of the object. In fact, I wrote a paper just a couple of months ago saying that from data that we have on the amount of heat that the object emits as a result of its friction with the air around it, just from that level of heating of the air as it moves around, and also how much it moves in the sky, we can infer a lower limit on the mass density, on the mass per unit volume of that object, which is, I found it to be a very interesting result. You can just learn how dense the object
Mm.
is just from seeing on the sky how fast it's moving and measuring how much heat it's producing from its friction with air. And that is interesting because we have those measurements with our instruments in the Galileo project. And if you find the mass density from this constraint to be more than the highest density of solids that we have on Earth, that would obviously make the object extremely anomalous, because then the question is, what is it made of? And you don't need to know the distance to the object based on the equations that I wrote in that. I should also say, I uh, when you said before that I'm not interacting with the UFO, that's not, I gave a lecture actually in November at the Seoul conference. That was one of the
Yeah.
primary lectures there. And in fact, when I finished my talk, I went to the men's room. So on the way there, every few meters, someone would ask me for a selfie. By the way, when I got to the men's room, someone was just drying his hands, and he said, "Are you Avi Loeb?" And I said, "Yes." And he said, "Well, it feels like standing next to Taylor Swift."
I didn't mean to put you down,
So when
sir.
you
Like, I honestly, me being able to talk to you feels like Taylor Swift. I was nervous this morning. I could meet Taylor Swift, and I just be like, "Oh, it's Taylor Swift." Talking to Avi Loeb, I'm sitting here. I'm like, "Oh man, I gotta get ready. I gotta get in the right mindset." I'm talking to a legend right now, so no, I didn't mean it that way. I just meant you don't really
no, no,
interact
no.
with a lot
I
of
mean,
the, top.
that's not what I meant is that I really am enjoying interacting with any person, and it's not like I'm shying away. It's just that I don't have presence on social
Yeah.
media. That's
And I
that's
hope
all.
to ask a lot of the questions that people out there kind of have. I've seen a lot of your interviews and discussions and what have you, and this is where I'm going to press a little bit more on this topic. So let's assume I want to do two things. First is I want to assume what you just told me. You I think answered the question pretty well in terms of I need to know more data. So assume first of all two scenarios. One scenario is we've got a flying saucer. I'm just going to use this can and not show any ads. This can is a flying saucer, so it's got mass on it. It's a solid object, so we know that.
Right. By the way, Oumuamua was most likely flat, based on a very detailed paper that modeled the variation of reflected
Mhm.
sunlight from it at a 92% confidence. This is a paper published in the Royal Astronomical Society, monthly notices of the Royal Astronomical Society. The best fit to the shape of Oumuamua was that of a pancake.
Yeah, I saw that, and I also saw the anomalous kind of acceleration that it had as well. So that was an interesting one. But to me,
Okay.
there you're presenting the argument that we're just using like long distances and time is our energy source, as opposed to if there's really something like the Tic Tac UFO is kind of what I was getting at with the Nimitz situation that can move around like this. There's no onboard fuel based on our current understanding of physics that can
No.
accommodate for that type of
So,
movement.
so there, I'll tell you what I would like to know is obviously we have no access to the
Mhm.
actual data, which is unfortunate. But I would like to know, m- there could be some confusion if there is a swarm of objects. You might not be able to identify the same. So you see an object very far, and then you see it very close, but you don't know if it's the same object. So it's the situation is similar to seeing a black car behind you in your rear view mirror, and then you see the black car in front of you, and you say, "Wow, it must have moved really fast." But without reading the license plate number, you can't really tell it's the same black car. Okay, so there are all kinds of issues like that, and I would love to be flooded with data so that we can make sure that we interpret it correctly. But unfortunately, we are not given that data. It's possible the government has it. It's possible that the government has in its possession some materials or actually even technologies that were developed by extraterrestrials, but I would like to see
Yeah.
them. Otherwise, just talking about it would not advance our knowledge. We will not know if this is credible or not. And when you see, for example, just last night, there was a report by a helicopter pilot about an egg shaped object that was picked up with a rope. You know, lots of objects can look like an egg, and many of them are made by humans. And so the question is, what is inside? You know, like what's the substance? I mean, I a member of the Galileo project, Andy Mead, his grandfather received the National Medal of Honor for because in the Second World War, he was involved in deceiving the Nazis and basically putting sort of objects that look like tanks, which are just inflatable, that are not real tanks, and making the noise of tanks so that the Germans would think that there are real tanks out there. So, you know, you can't judge an object just by the way it looks or sounds. You really have to get as much information as possible about the inside of it, and that's what we are missing at the moment. And you can't, you know, eyewitness testimonies are not reliable. FIFA, the Soccer World Organization, already knows that because they use cameras, you know, to decide about disputes on the soccer field. They would not go around and ask the players. They would collect the data and look at it.
Um, you know what? I wasn't gonna do this, but can I show about 30 seconds of a video for you, and then we can jump into
Sure,
some other
please
stuff?
go
Because
ahead.
my opinion, this is going to be very controversial, probably what I'm about to show you here, is that this video that I'm about to show you is exactly what you're asking for. Is this is some of that information that maybe the government has or videos that the government has. This is a thermal video here that we're looking at. Just ignore the plane for now. I
Okay.
just want to focus on these orbs
Oh, the object
because of
next
what
to
you
the
said
plane.
about the mass energy density of these objects and these UFOs. If this is real, I want to point
Oh,
out you
wow.
can see it's very faint, but you can see there's dark lines in front of these orbs, which represents a cold signature. And you can tell that there's
Mhm.
a heat signature in here. I couldn't stop thinking about this when you were explaining the mass energy density. Because I think this is a ball of plasma, and that would be your medium for this UFO, which and this part, I'm just going to slow this down so you can see it very closely and clearly because I want to understand in the context of what we're seeing here, um, the physics of what we're going to talk about with dark energy, dark matter, this idea of there being like an ether 0 point energy. The reason why I believe in those theories is because of what I'm looking at right here. I mean, look at that heat signature on this orb.
Oh yeah, that's very interesting. Now, who took the images?
So, without going into too much of it, that's Malaysian Airlines Flight 370, the plane that disappeared 10 years ago. And
Oh,
what you're about to see here
oh, interesting.
is the most controversial
Yeah.
thing kind of on the internet recently is that plane's gone. I'll play it again so you can see, but
Okay. Now, do we know that these images were not
we don't
manipulated, that
know
they
with
are
any
real?
level of certainty. I don't want to like have this whole
Mhm.
podcast be about that, but I just wanted,
No, but
yeah.
that's very interesting. I mean, I'll be glad to look at it more
Some people
carefully.
think
But
that these videos are fake and
I
that they're
need more.
debunked and what have you. Other people, including myself, think they're real. But
Okay.
the reason why I bring it up is not just random. I'm not trying to promote myself here. Is that we see these dark lines
Mhm.
in front of these orbs, and that seems to be their propulsion mechanism. And what we see right
Mhm.
here is also all black when this plane disappears, which
Mhm.
means it's cold.
Now, the camera that took these, where
So
was it
this is a
situated?
drone
Was
that's
it
taking this. This is a General Atomics drone. You can see it in the beginning of the video right here.
okay? I wonder, for example, whether there is any footage from the U.S. government satellites
Funny
of
that
that
you
airplane.
asked because
I
there's a
mean,
second video. And I don't mean to knock you
oh
down the rabbit hole right now, but there's a second
no, no. I
video
mean,
of the
any
same
data
exact
is
event
interesting.
from we found out this is like
Okay.
this is Sibers. When you mentioned Sibers, like we found out this is Sibers.
Mhm.
This is the space-based
Okay.
infrared system, but this is actually more than what the public's aware of. It's not just like looking through satellites. They can beam all the data together, and then it can create a computer-generated video, which you're watching, and you can see the coordinates in the bottom left too. So this is the
Yeah.
same thing from a different perspective. I'll just let you watch it because
Right.
I guess you haven't seen it.
Well, that's very
And
interesting.
the reason why I brought this
Uh,
up, sir, is just
and this could
because,
not.
you and a lot of people talk about wanting
Mhm.
evidence. And I've been the same way as you, have had the same
Mhm.
thought process as you. The only reason why I have a podcast is because I saw these videos and I went, wow, I mean, maybe that's fake, but what if it's real? What if this is really what happened? I mean, look at what you just saw right there. And this has led me down a journey of discovery. I'm going to stop sharing for now, where I've been trying to understand this physics and this science. And truthfully, just to open up here for a second, it's led me to you because I've watched a lot of your stuff and you're not afraid to talk about these concepts where everybody else is afraid that, oh, what we're seeing and what we're talking about violates the laws of physics. It can't be possible.
No, no, that's not really. I don't think there is any violation here because we are talking about speeds that are relatively mild, as the speed of an airplane. But what I would like to know primarily is who provided these videos because we need to make sure that they're not
Yeah, I'll
fabricated.
give you the short version. There's a guy named Lieutenant Commander Edward C. Lynn that went to prison for he got a 9 year sentence. And I've identified him as the guy. They started looking into him right after the plane disappeared. He was flying on spy planes. And it's very likely that he either leaked those directly or he showed somebody else and they got on the internet that way. Um, and yeah, and there's a plane that's been missing for 10 years. And somehow there's two leaked videos. It turns out they go all the way back to May 19th, 2014. So they're 10 years old and they only recently got attention. And it makes me wonder if we had to get to a level of consciousness where we could accept some of these scientific possibilities, physics possibilities to be real.
Oh, it's not a matter of consciousness. I think it's just a matter of good data, because you know Ryan Graves was claiming that there are a lot of objects that pose a risk to pilots, and he's advocating for safety. And what you are saying is very similar to what he's saying, that perhaps this flight was affected by these objects. Now, he is very concerned about the safety of pilots, and he has an organization dedicated to that. And I encourage you to show him
Yeah, and I think the
these
difference
photos.
here, and this is the crazy
Yeah.
part about those videos, is that that's not aliens. That's not aliens we're watching. Because that's the US military filming that on two different assets, from two different angles,
Mhm.
that's an operation. And this is where it starts to get really dark. And I don't want to go into the conspiracy rabbit hole with you, but it's like if this is true, all of everybody's worst fears in the UFO community about the US government hiding technology, reverse engineering it, they're all true. And then the further implication is, well, how far would you go to prevent China, Russia, North Korea, Iran from getting this technology?
Well, we know that at the same time there was the Chinese spy balloon that was shut down, and there are objects above the U.S. that are not identified, obviously, because that balloon was 40 meters in size, and smaller objects would be even more difficult to detect. And there was, of course, the incident over New Jersey for several weeks, where citizens complain about. And it's clear that that is not extraterrestrial because, first of all, the objects were moving
Mm-hmm.
like drones, okay? And secondly, once the law enforcement got into business, um, there were no more reports. I mean, we don't hear them now. And so it's clearly human related. And the only question is whether that was these were drones from adversarial nations or
Do you think
from
it's
the
possible
US.
that we have or that other countries have a level of technology that's beyond what the public's aware of?
Oh, I mean, there are lots of reports about China being similar, if not ahead of the US in drone technology. And drones are extremely important for national security now because in the battlefield, in fact, Elon Musk was advocating using drones and not training pilots traditionally. And we've seen them being used in the Ukraine war. So drones are definitely a very important asset now for combat and also for espionage. And so the only question is how many of them are being used right now that we don't even
Now,
notice.
go ahead.
Now, yeah, I should say that we obviously within the Galileo project, if we see drones, we will identify them as drones based on their flight characteristics and the way they appear, and we are actually calibrating our instruments based on drones. And we had a paper just a few months ago that provided the first commissioning data of 500,000 objects in the sky over 5 months. This year, I mean, 2025, we hope to get of order more than 1 million objects monitored in the sky. But from the 500,000 that we had analyzed, the we posted the analysis without having triangulation, without having distances. And as a result of this paper appearing publicly, we were contacted by a professor who is doing studies of drones, and he wanted with us to explore the ability of our cameras to detect drones. And that's a very good calibration for us because we would know where it is, how far it is, how bright it should be in the
You're
infrared.
filming in
So
infrared or what? How
um,
are you? What sensor data are you using?
yes, currently the workhorse is a set of 8 cameras that are covering the entire sky in the infrared, and they are placed on a half a sphere. They look like R2D2 from Star Wars, and this is called a Dalek instrument, and it's all in our paper on the commissioning data that one can find, from a couple of months ago. And in addition to that, we are observing in the optical, in the radio, and also recording acoustic data and magnetic data as well. So we're trying to use all the instruments we have access to within our budget.
So let's get more controversial with it. This is going to be a great interview. So what I learned from researching those balls of plasma that I was showing you earlier, or whatever, was that really the big secret was that space isn't really empty. And I watched your interview with Jimmy Church, Fade to Black, and several others, where you've also mentioned that there's this energy density of space time. Well, it seems like quantum physicists call it 0 point energy that's out there all the time. And one of the things I found out was that once that got realized, people started figuring out they can make balls of plasma that are like autonomous, like self-sustaining, like there's a invisible field creating like a bubble around it pretty much. And so then I start looking back at all the stuff I was taught in physics because I'm not really, I didn't go to school for physics, but I love science and physics. And I realized like, oh wait, well we have this stuff dark matter and dark energy. It's supposed to explain the stickiness that we can't otherwise explain. And I start wondering, like, can this just explain all of that? And turns out there's this ether hypothesis that's been out there forever, and the Planck ether hypothesis by Friedwart Winterberg, who was a Project Paperclip scientist that came over. What are your thoughts on all of that? I've got to know. What do you think about the ether, and do you think
Okay.
that that's
So let me first explain what these
yeah?
concepts represent. So um, we now know that the universe is not only expanding. I mean, we knew that for a while, for about a century, that the universe is expanding. But in the second half of cosmic history, the universe is accelerating. In other words, the expansion rate is increasing, meaning that a very distant galaxy away from us is not only receding from us, but the speed at which it's receding is increasing with time, and eventually it will exceed the speed of light. Okay, so we will be left in the darkness in the distant future because all the galaxies that are far away from us are running away at a speed that keeps increasing. And once they reach the speed of light, even light would not be able to bridge the distances of those galaxies from us. So we won't see their whereabouts beyond a certain time. They will exit from our cosmic horizon. Okay. So we know the universe is accelerating. And according to Einstein's gravity, the equations that Einstein wrote back in 1915, November 1915, you can accommodate repulsive gravity. In other words, we are used to the fact that if you throw an apple up, it falls down, right? So that's what Newton associated with gravity being attractive. But just imagine throwing an apple up and the apple keeps running away from you faster and faster as it moves away. And that's repulsive gravity. It's exactly the opposite sign of gravity, where things are running away instead of coming together. And according to Einstein's equations, that can be simply a result of the vacuum itself. If you remove all matter, you are left just with a vacuum. And if the vacuum itself has some mass per unit volume, even if it's constant everywhere, it will have exactly this repulsive gravity effect that will cause the accelerated expansion of the universe. So this is the current standard model of the universe that includes some energy or mass per unit volume for the vacuum, which is called the
Mm-hmm.
cosmological constant. But physicists framed it in terms of dark energy. They said, oh, the vacuum has some energy that per unit volume that we don't know its nature, and we call it dark energy, so that maybe it's not constant, maybe it evolves over time, and there are some hints that it might. At any event, the reason it's important in the context of what you asked is because if we had a way to bottle that energy, to basically put it inside a vessel and concentrate it, then you would get a negative mass. Okay, concentrated. It will not be spread everywhere like the vacuum is. It will be concentrated. And that, if you have negative mass, you can do two things. One thing is you can propel a spacecraft with no fuel, because you would have this negative mass and it could push a positive mass away from it, while the positive mass is attracting the negative mass with it. And so you would end up accelerating, this system will end up accelerating up to the speed of light with no need for an energy source. So it gives you a means of propulsion, this negative gravity that otherwise you cannot access without fuel. And the second thing is you can show that you can build a time machine. If you had negative mass, you can go back in time. Now, we haven't yet found a way to, we don't understand what dark energy is, and maybe aliens do, and maybe they're able to engineer it in some way to create a negative mass. If they're able to do that, then they have a way of propelling objects without any fuel. Okay, so that to address your question. Now, the issue about plasma, and by the way, plasma physics was the area where I focused for my PhD. That this was the subject. I worked on a project that was funded by Star Wars, the initiative of President Reagan, and actually General Abramson that led this Star Wars initiative back in around 1985. He visited Israel, where I was born, and I presented the project to him. And that was the first international project that was funded by Star Wars. And it's sort of ironic that I started in Star Wars, and now I'm discussing interstellar travel. But that's what brought me to the US, because we got funded by Washington. I used to visit Washington, D.C. And then in one of the visits, I went to the Institute for Advanced Study at Princeton and was offered a 5-year fellowship in astrophysics. That was the condition. Only if I switched to astrophysics. I was a plasma physicist before that. So I switched to astrophysics, and then I was offered a position at Harvard, where I am right now. And so my interest in astrophysics was a result of circumstances. It was not planned, but I now have this freedom of addressing problems that I find to be consequential and exciting for the future of humanity. And that's why I'm back to this subject of interstellar travel. Um, and I should say that in the context of plasma physics, plasma is, if you just deposit heat into a small volume, like in an explosion, you end up with very hot gas in which the atoms are broken into their constituent electrons and ions. So you end up with a fluid that is made of charged particles. That's what a plasma is, a fluid made of charged particles. And it's a result of any deposition of heat into a small volume that usually results from either focusing lasers or detonating something, or but actually most of the universe is in a plasma state because of the ultraviolet light that was emitted by stars. That ultraviolet light uh, breaks hydrogen atoms into electrons and protons, so you end up with most of the hydrogen in the universe being in a plasma state. There is nothing magical about a plasma. It's just a state where you break the atoms and molecules into their constituent electrons and ions. That's all. So when you say plasma ball, it's just a region of space where some energy was deposited. Okay, so then the question is, what's the energy source that created this plasma? And that's really the key question. And what was, how much heat is emitted by this plasma? We can detect heat with infrared detectors, but the concept of a plasma is nothing mysterious and nothing fundamental, not as fundamental as dark energy that I was talking
Well,
about before.
I would say there's something kind of magical about it. Lightning. Why does lightning happen? Lightning is plasma as well. In fact, they call these balls
Yeah, so lightning. So I can let me explain that. Basically, what happens is clouds. They're made of water vapor, right? And as they move through the atmosphere, they get charged. Okay, they get a net electric charge. And then when two such clouds get in contact, uh, there is an electric current. If they don't have the same voltage, there is an electric current flowing from one to the other. And that often happens through breakdown of the air. So you end up with the air is the conduit, it's like a wire in which you run the electric current. And because you are running an electric current through the air, you basically heat up the channel of air in which the electric current is going, and that's the lightning. So you see a very bright streak on the sky because this is a region, a channel where uh, electricity heated the air to become very hot and luminous, and you see it as and you also hear the sound because what happens is once you hit this channel of air, there is a high pressure in it, and pressure runs away from that region in a shock wave or a sound wave that eventually reaches your ears. But sound propagates a million times slower than light. So at first you see the light of the lightning, and then you hear the thunder, and that's all there is to that thing. So it's basically what you see when there are these bright phenomena in the atmosphere. You see regions that were heated by electricity,
yeah, and we can
basically.
manipulate that. And that's the thing where ball of lightning is a ball of energy. And so you were just mentioning if
Right.
we could or aliens could make a warp drive, Miguel Alcubierre's warp drive metric, we're talking about adding or removing negative and positive mass, and mass is energy, is what
Yeah.
Einstein showed us. So if you can make a ball of energy,
Right.
that
Right.
seems like the
I mean,
perfect conduit for trying to produce, a warp drive metric, in my opinion, because it's a huge condensed ball of energy, right? That's my thought process.
yeah, well, okay. So there are two parts to this. Just the object moving through air. If the object interacts with the
Mm,
air, like any object does, um, there is
mm,
heating of the air. Okay, that glows around the object, and we see that when meteors enter the atmosphere. We see that when rockets fly through the atmosphere. There is heating of the surface of the rocket when as a result of its friction with air. So that's one part of the plasma, like it's basically the heated air, the amount of energy given to the air by the motion of the object. Okay, that's one part of the, and there is a second part that you are referring to, which is the
mm.
propulsion system, which must generate some energy and perhaps potentially be visible. So when you look at an airplane, you can obviously see the heat
Mhm.
emitted from the exhaust, which is basically related to the engine. You can also see the heat emitted from the contact layer between the airplane and the air. So these are the two components that have nothing to do with each other. Just the fact that the object is moving generates plasma around it and some heat. But there is also the heat, the energy source that propels the object, which is a separate
Yeah,
matter.
and that's the part where going back to the videos I was showing you earlier, seeing endothermic propulsion blew me away because, like you said, I would expect to see some friction happening, which shows that somehow they found a way to make a bubble. Now, long story short, done a bunch of research, Air Force Research Labs, Jack and Champion, they figured out how to stabilize balls of plasma, so they can make them stable. Right?
Yeah. No, I mean, and so one thing to keep in mind is that radar systems respond to the reflection of radio waves from those plasmas generated by fast-moving objects. So obviously, the military wants to reduce the signature of any object to radar systems. And one way is to reduce the cross-sectional area to make the object flow through air such that it has a very minimal cross-section, and as a result, very little signature in radar systems. And so human-made objects that are used by the military are minimizing the amount of plasma generated around them
Yeah,
as
they
they move
also
through the
reduce
atmosphere.
drag as well. They use plasma sheaths for our spy planes as well.
Yeah.
So I just thought, oh, this is the perfect conduit. If you were to make an anti-gravity ball, you would just get rid of the plane and the person and just be left with your ball of plasma. And now that thing can just float around. And
No, but you need to put the object with its engine
yeah.
inside, and that's really the key. The key is not so much what we see, but what is there. And that's that's something that we can collect data on by observing it or retrieving anything from
So let me
crash
ask you,
sites.
because there's
So
one I want
yeah.
to ask before I forget about the negative energy aspect of it. Because I looked into that, and it turns out there's people like working on negative energy lasers, and there's a professor out of NYU named David Greer who has like a tractor beam laser as well. But Eric W. Davis, who's been connected to the UFO topic, openly talks about them trying to amplify negative energy and isolate negative energy from positive energy and light. And if that's true, then what I imagine those orbs are using is some kind of laser that's pulling energy out of the vacuum as opposed to adding energy to the vacuum. Have you ever heard of anything like this?
Well, in principle, as I said before, in principle, it's possible to um, activate the vacuum and pull energy out of it. But these concepts, I mean, there are various effects that are well known. For example, if you have two metal plates um, and you place them close to each other, you are changing the vacuum in between them because you are allowing only certain modes of the electromagnetic field in the vacuum to exist. Because the metal plates place boundary conditions that allow only certain wavelengths of the electromagnetic modes to exist between the plates, and as a result, you get some force acting. This is called the Casimir effect, and it has to do with the vacuum. And but it doesn't allow us to propel anything. And of course, you can speculate and imagine. And I've seen some documents where people like Eric Davis speculate about what might be doable, but I should say there is nothing at the moment that allows us to construct a propulsion or imagine a propulsion system. I've been working with a group that, we asked the question: is it possible to create a negative mass object, just that will produce repulsive gravity? And we had to imagine the existence of fields that we don't know exist. It was not the electromagnetic field; it was now, I cannot exclude that such fields exist and are known to another civilization, and we are just, as I said, in the making the baby steps in understanding quantum mechanics, gravity. So I wouldn't exclude anything. I would just say, let's just learn from them. Okay, so if we find anomalous objects moving in anomalous ways, we should just get as much data as possible about
So
them. That's
I
all.
feel like you did kind of answer it though. And this is the part where I kind of want to push you on because you said now that we've got this dark energy that's causing the universe to expand outward and it's this negative gravity, repulsive gravity that we feel.
Yes.
Well, when Eric Davis and other people explain the Casimir effect, they explain this as negative energy. And anything force is just described as defined as the ability to do work. So if we're seeing plates magically come together on their own, there's some force that's happening there.
Oh yeah, no, but that's that was known for the past century. That there is nothing really new about it. The only question is, can we actually propel an object using a device that takes advantage of the Casimir? I mean, so what Eric mentions is all speculation about, maybe we could engineer something, but there is nothing behind it because this technology was never attempted. As far as I know, he would have gotten a
What if they
Nobel
just don't
Prize
care
if he
about
could.
Nobel Prizes? It's a scary thought, right? But
It's not a scary thought, but I don't think. uh, you know, I think we would learn about it because somewhere, sometime there would be a leak of this technology, in some context, and haven't heard
Okay.
anything.
Let's come back to that thought in a second. So the next step I would say is like the EM drive, the impossible drive, I would argue is basically just taking the Casimir effect and making a slight asymmetry. And then you're going to get a pressure, a force pressure going downward. Then you use that to move through the ether of energy that's out there. Um, Actually, what I really wanted to get at was that the dynamic Casimir effect. I was curious if you've heard of that at all, but also, and the dynamic Casimir effect for people who don't know is this idea that you can pull so much, or you can put so much electromagnetic flux or energy density within a region that we can actually pull those virtual photons into real photons, real light that comes out. And they think this happens at the edge of black holes as well. Because I'm looking at, like, for me, it's a matter of just engineering the problem. Once you've shown me that two plates come together like this and that there's this negative energy pressure, now I'm sitting here wondering, what is negative energy? Maybe it's not this swirly mass of substance. Maybe we're thinking about the problem wrong. Maybe it's just a pressure. That's what the energy is. And maybe if that's the case, then we just have to look at it as an engineering problem. And it takes me back to plasma, where I realize, well, the issue with the plates is once they come together, I got to pull them back apart. So what if there's a way where I can just have this permanent situation where I'm getting this free energy, or like a bounce, like a trampoline or something like that? But with plasma, when I started to research it, one of the things I learned is that the plasma changes the permittivity of space-time. And this changes the refractive index. So bear with
Of
me for just one second. I want to
electromagnetic
give a
waves.
quick example and then I want to get your opinion on this. Is that if I were to take, let's say, a cube of water from the ocean or the lake, and I were to remove all the things inside of it, and I were to show someone just that cube, and I would say, what do you see in this? They would probably say nothing. And I would go, you're wrong. There's water inside of that. And they go, well, I just see an index. And I would say, well, let me shine a laser through it so that you can see that the refractive index bends and changes. Well, you can do that same thing with outer space. It's only going to change a little bit based on wherever medium I'm in, but it's going to change. My idea that I'm presenting here is that a fish stuck in water doesn't realize it's in a fishbowl. It looks around and it says that everything else is empty around it, but it's obviously not necessarily empty. So if we were to change the speed of light, change the refractive index in a plasma or any other medium, what does that do to general relativity and to the physics equations? That's the question for you, Avi. Professor Loeb.
Yeah, so in fact, we see the effects that you're talking about are observed. We do see the effect of gravity in bending light. This is called gravitational lensing. So when you have a positive mass, let's say of a cluster of galaxies, usually 10 to the 15, a quadrillion times the mass of the sun, it can bend the light from sources of light behind it. And we see these beautiful arcs where uh, a background galaxy was actually stretched to a ring around the center of the cluster. That is called gravitational lensing. We also see the same effect when there is lensing by a star. If you have a background star behind a foreground star, you can get gravitational lensing. Albert Einstein realized that this effect should be observable potentially back in 1940, but he didn't imagine the kind of data we have now. Now, if so, this is gravitational lensing by having a concentration of mass as the lens. But there is, of course, a possibility of lensing by a plasma, because, as you said, there is a refractive index to a plasma, and it turns out to be of the opposite sign. So if you have a concentration of plasma in a certain ball, then it actually, the light would, rather than being focused, it will diverge by passing through it. Okay. In order to focus light, what you need is a region where there is less plasma than the background, and then it would focus light. And we do see in astrophysics circumstances that show that. We detect radio signals from pulsars, for example, or radio sources. We see the effects of the plasma on those radio signals, because the effect of the plasma depends on frequency, and we can see that frequency dependence. So what you are describing is observed in the universe, but there is nothing really magical about a plasma in terms of propulsion. The way I think of it is, if there is a system that has some novel propulsion abilities as a result of some unusual engine of a technology we don't possess, then there might be a plasma around as a consequence of that engine moving the object, but that's not the essence of the thing. And of course, we can observe the plasma because we use infrared or detect the heat, but it's the fundamental question is what's the engine made of? And if there is any such engine in possession of the U.S. government, I would love to see it. Okay, and then I
Well,
can
what
tell
if
you
it
my
was
opinion.
just manipulating the ether the same way the submarine floats down through the water? At that point, all you need is like
Yeah, it's possible.
magnetohydrodynamic flow, and then you can just
Yeah, it's definitely
mm,
definitely possible, and
okay.
but I haven't seen that demonstrated by any engineer
Yeah,
at the
and
moment.
I don't want to harp on it too much. I would just challenge you that, I mean, at least my opinion, I think a lot of other people's opinions, not necessarily common, is that, they're hiding some of this stuff from us, either using the Invention Secrecy Act of 1951 or the Atomic Secrecy Act, where they claim some of this is related
Yeah.
to like nuclear weapons and things like that. Therefore, they protect it. That's how the story goes.
Well, if that's the case, I think it's completely inappropriate because if objects arrived from outside the solar system, they should be the subject of science, not of national security concerns, because they started their trip towards the solar system long before humans existed,
Mm.
probably on Earth, and obviously they don't care about borders, nations, and any knowledge related to what lies outside the solar system should be shared by all humans. It's part of the reality that we live in. It's just like trying to classify the knowledge that the Earth is not at the center of the universe. Now, the Vatican tried to do that when Copernicus argued otherwise. And, in 1992, the Vatican admitted that Galileo was right. That was 20 years after the first humans reached the moon, a little bit too late. And what I'm trying to say is that hiding information is not to the benefit of humanity because eventually we will learn it. It will take more time, but it's actually to our advantage to know what the reality is because we can adapt to it. So once we realize that we're not at the center of the solar system, that Mars, for example, does not orbit the Earth, we could launch rockets that would reach Mars because we understand through the laws of Newton how Mars moves around the sun. If we were to think that Mars moves around the Earth, like the Vatican was arguing, we would shoot rockets like crazy and never reach Mars. So my point is, even if the reality does not flatter your ego, you better adapt to it. I mean, it's sort of like you having a disease and you say, I don't want to hear that. I will never die. Is that good for you? No, because if you know what the disease is, you can fight it. You can adapt to it in some way. It's much better, in my opinion, to know whether we have a neighbor, because once we realize that, we will recalculate, just like a
Mm.
GPS system, we will recalculate the next steps accordingly. But if we ignore that, if we hide it in some classified documents, that's actually a sign of us not being intelligent.
I think it's out there. I think that it's hidden in plain sight, and I look forward to people like you, sharpening your pitchfork, you and Eric Weinstein, to go down to the National Science Foundation and demand, because like you just said, the Vatican already did it once. Do you really think that the government wouldn't do it again? I think that they might, but your point is perfect, and I've said it many times on my live streams, is that you can't hide this
Yeah,
forever,
well,
no matter
I,
what.
I try to express my opinion with the transition team of the new administration, and I'm not sure if anything will happen. There are two possibilities. Either the government has some very interesting information, or it doesn't. And if they don't, then there is nothing for us to learn about from them. If it exists, I hope that they will share it because it's of great value to science and humanity in general, and it will save me decades of work. I mean, I will work at it, but if they already have something, I would love to
So
help
let's
them figure
press it
it
even
out.
further then. Okay. So I'm going to tell you, I'm going to give you a hypothetical scenario. I just want you to run with this, assuming this is true, because I think if we play out the scenario, you start to realize maybe it is. what if the alien technology represents free energy? And by free energy, I don't mean from nothing. I mean that this 0 point energy all around us turns out it's not this tiny amount.
Yes.
The answer to the vacuum catastrophe is that there's this huge amount of energy. The aliens have figured out how to tap into it. They don't need solar power or anything. They've got energy everywhere all around them all the time. Now, imagine
Yes.
how, what would that civilization look like if we realized that that technology exists? Imagine how the US government might try to weaponize that technology. Imagine what that would do to our entire society. So, would you still be on the side of disclosure if that's the case, where we would potentially be handing over free, unlimited energy to every person on the planet that might also, to your point earlier, be a time machine as well? What,
Yeah, so this question comes up again and again when science uncovers new knowledge that we did not know before. And it was true in the nuclear age when we realized nuclear physics. And then you can imagine using nuclear energy both for destructive measures, nuclear weapons, and at the time it was World War II, it was quite dangerous if the Nazis were to develop that. And Werner Heisenberg, one of the founders of quantum mechanics, was leading the Nazi effort. So that was a real risk. And of course, the second option is to use nuclear energy for peace and prosperity. That can be a very useful source of clean energy, much better than any other source. So we always have, whenever we understand reality better, we have the options of using it to our detriment or to our benefit. And that will remain. Now, I don't think the solution is to argue we should go back to to the Stone Age. Okay. I'm not a believer in the philosophy of Thoreau, Henry Thoreau, who lived very close to where I live. He went to the Walden Pond and stayed there for a year, arguing that the Industrial Revolution is really harmful for our interaction with nature. I don't think so. I think, for example, if our technologies, for example, change the climate, it doesn't mean we need to go back to the Stone Age. We just need to develop new technologies that would moderate the impact of our technologies on the planet. So, in other words, we can solve our problems with better technology, not by reducing our level of technological innovation. So, we should always be motivated to use it for a good cause. And therefore, we should never head back in time. Okay, we always move forward. It's just like riding bicycle. You always need to move forward in order to stay stable. If you argue that we should stop, using cars, airplanes, and so forth, just for the benefit of the planet, you are really not thinking ahead, because what needs to be done is developing technologies that would moderate any impact we have and remove, actually compensate for any impact that we did already have on the planet. And the same holds for your question. So suppose there is an alternative source of propulsion that we are not aware of. You know, we can definitely use it for the benefit of humanity. We can propel people out of this planet much more easily. We can solve all of our energy problems. People will live better, will have better life. The same is true about AI. There was this memo that was written by a group of experts that tried to argue that any development of AI should be stopped for 6 months. That was a year and a half ago, and I thought that makes no sense, because okay, you stop it for 6 months. What do you do next? And really, what needs to be done is making sure that AI will not harm society, and there are many possible risks, and I write about them in my essays. And as long as you are aware of the risks from AI, harming national security, harming the mental states, the mental health of young people, as long as you're aware of the risks, you can develop ways of mitigating them and progressing in a more constructive fashion. And so, in the same spirit, if we have access to a new propulsion system that far exceeds our technologies, I'm not worried about it, because we can always use it to our benefit. And there would be some bad actors always. There are Imagine nuclear weapons falling to the hands of terrorist organizations. At the moment, they don't possess it. Imagine AI being used by terrorist organizations. That currently it hasn't happen. So you can imagine any new technology that could have devastating consequences, including, biological warfare. You can imagine those getting to the hands of bad actors and then damaging the future of humanity. But of course, if you arrange your geopolitics such that bad actors will be punished very severely and nobody would cooperate with them, then these bad actors will not have a global impact. They might have, they might do some act of terrorism in a particular place at a particular time, but after that, they would not survive, okay, because there would be an immediate response to that. So my point is, as long as we use what we learn for our benefit and not use it as a weapon, we can survive for a very long time. In fact, knowing better how to propel ourselves would make the longevity of humanity much longer than the next century. I mean, we will leave our planet, go elsewhere. Just imagine, instead of using this traditional rocket technology that Starship is based on, if we were to use something much faster, much more efficient, everyone would love to go on such a
That's what
space.
spooks me about those videos I showed you earlier is that when I watch those, I go, wow, like that's very similar to Miguel Alcubierre's warp drive metric, but they don't have a fixed structure attached to the plane that they're zapping out of the sky, or at least it looks to be moving at relativistic faster than light travel. Now, what the conclusion I've come to, I love all your opinions, by the way, but that with this UFO stuff and everything is that the answer must be really dark and free energy and the ability to teleport around and using all these propulsion mechanisms. That's a pretty dark answer. It means like we're basically just ants, and either the aliens are pretty much just gods compared to us, or maybe AI won a long time ago and this is all
Well,
simulation.
I don't see it as dark. I see it as uplifting and inspiring. Just imagine that you are in a class and there is a smarter student in that class. Why is that depressing? It's uplifting. Imagine all the students were stupid, like then I would be depressed under these circumstances because there would be nothing to learn. Okay, but if there are neighbors that are far more advanced than we are, we can learn from them and do better. I mean, when I look at the news every day, I
Me
really
too.
get depressed. I get depressed by how not intelligent we are in the way we interact with each other and between nations. And just having someone to be inspired by that is better than our politician would be a great thing.
I'm 100% with you on that. And I love that because I'm really pessimistic about this. Like, looking at this science, I'm like thinking like Oppenheimer, like, I am become death, destroyer of worlds. Like, I keep thinking, like, this is going to be the end. This is the Fermi paradox. We're staring at it. That's
Oh
why
no,
they're
no.
hiding it.
So on this, I must say on this that um, reality is very often a self-fulfilling
Mhm.
prophecy. Okay, so it's better to be an
Mm.
optimist. If you are a pessimist, um, very often you will end up fulfilling your prophecy and not enjoying life. And if you have something that inspires you, that could bring reality to a better place, there is some chance that you would realize that. And therefore, in this context, first of all, I don't think that humanity attracts a lot of attention. I don't think that we are sufficiently intelligent for them to care about us. If they arrive at our vicinity, it's not because they care about us, it's because there are some other resources that they might want to explore, and we happen to be here. But for us, it's a great opportunity to do better because we, technologically speaking, we are just roughly a century old, and we can learn from someone that was around for 1 million or 1 billion years. Just think how many opportunities they might have that we
I'm
don't.
with you 100%. And I think I remember I watched when Jimmy Church asked you actually why you do this. And it's like, I'm looking for someone smarter out there. I'm looking for someone that's not, the way I interpreted it, someone that's not just on TikTok all the time or just constantly talking about social political issues. Somebody that's like actually trying to make the world like a little bit better or looking at it from a higher level. And the reason why I say this again is that and this would be me challenging you on it, you have some amazing thoughts, but like, imagine even bigger, where a scenario where the aliens aren't even biological aliens anymore. Maybe they're a hive mind. Maybe they've figured out free energy and now the sun doesn't matter and the Kardashev scale is basically irrelevant. And now you're a species with no scarcity whatsoever. You have no scarcity. So now resources, that doesn't even matter anymore. That's wild to me because
Right.
I think that in a scenario like that, AI wins. Like AI, I would upload my
Oh
brain
yeah,
to the computer because you have infinite
it's quite
energy.
uh, it's quite possible. But suppose that intelligent life or complex life on Earth was seeded, by a gardener. That was an AI system that came along and decided to plant some seeds of complex life, and
Yeah.
here we are. Okay, so what kind of complex life would you plant? You want to plant self-replicating entities, and that's
Mm.
exactly what we are. Okay, so we use the raw materials on Earth to reproduce, to generate more and more, and evolve. And our technologies at the moment are unable to produce something like that. We don't have a robot that can manufacture a robot like it. We don't have that. We don't even have self-healing cars. When a car gets bumped, it doesn't heal. I mean, the human body, I just fell this morning when I was jogging because it was icy on the asphalt. Every morning I jog at sunrise, and it healed by now. I don't feel any pain. And so that's the amazing thing about biology. And maybe life as we know it was seeded, the complex life that we have was seeded, by some technological device. And if you think about it, it would be the best thing to plant, basically systems that are able to reproduce themselves and use just the raw materials. They have a brain, even the human brain, the most able brain on this planet as of now, before AI will exceed it. Even that requires only 20 watts of energy. That's remarkable because our AI system, ChatGPT, large language models, require gigawatts. So we are very sophisticated if you think about biology, the human body. And maybe it's not a coincidence. Maybe that we are the self-replicating probes on using the raw materials on the rock where the seeds were put. And the only way to find out is to find the gardener.
That's a great thought, Avi. And you know what? I think we'll probably end it on that. This has been an awesome conversation on the physics, on the science. My last question was going to be, what is your thought on non human intelligence? But I have a feeling you just explained it to me right there.
Oh, well, I think there are two types of AI. One is artificial intelligence. These are our technological kids that may supersede our abilities. They're already getting there. In fact, I just read this morning uh, that some people fall in love with large language models. They develop very close relationships, and um, eventually, we would realize it looks like an oracle because it is smarter than us. Okay, but there is another type of AI, and that is alien intelligence, which may also be smarter than us. And the question is, who would we find first? Because I'm trying to promote the second option, and I know that there are big tech companies trying to promote the first, and there is sort of a race. At any event, we will not be the only intelligent or the most intelligent species uh, within a decade. Either AI will, artificial intelligence will do it, or if we find evidence for alien intelligence, it will do it. And for me, finding a neighbor, is following the messianic message of traditional religions. The assumption is the Messiah will arrive and bring peace and prosperity, a better future to humanity. But I just believe that Messiah will come from
Huh.
another star.
No, for me, my opinion is that I don't really care about aliens. I assume that they're real. I assume that there's life actually everywhere out there. And to me, it's just a matter of like, unless they're changing my day to day, it just doesn't really matter that much to me. I think it's a cool idea and I love exploring it and I really appreciate exploring with you. But the stuff that would change my world would be if we can warp or teleport around. I can have a Stargate in my garage and if I have free energy.
Well, but that could depend on the first thing. So the point is, if you have someone that you can learn from, that addresses your second interest. And for me, they will give us inspiration and to do better. So let's look for them, and that's what I'm trying to. I'm not talking about them. I'm trying to
One
find
last
them.
question that I just came up with because you were talking about in a battle, or however you want to think of it, doesn't have to be adversarial, but in a competition or relationship between AI and organic life, do you see one being superior to the other? Do you see there being an integration of the two in the long run? Any thoughts on that?
Oh yeah, humans through natural selection were. I mean, the human body was designed to survive
Mm.
on Earth, protected from cosmic rays, very energetic particles by the Earth magnetosphere and atmosphere. And it's really very hazardous for us even to go to Mars. The surface of Mars, doesn't have the protection of an atmosphere, and moreover, the temperature changes by hundreds of degrees between day and night. And so when thinking about going there, you really need to solve the problem how to protect the humans. And one way is, of course, to go into a cave under the rock. So that would be just like going to prehistory when we occupied caves. If I ever go to a cave on Mars, I would like to check the cave walls to see if there are any prehistoric paintings there, because Mars had an atmosphere 2 billion years ago, and there could have been complex life back then. And so I would argue that technological gadgets like systems with artificial intelligence could be designed to survive interstellar travel. They will not get bored over the long journey, and they could be hardened to survive the harsh conditions of space. Moreover, you need a brain when you go large distances because you can't ask for guidance from the senders. It takes too much time for signals to propagate and bridge between you and the sender. And it's just like sending out your kids away from home. They will report back every now and then about the highlights of their journey. But if they keep calling you all the time, they can't go a long distance. It just takes too much time for the communication, it requires too much power. So in this case, I think technology basically equipping interstellar travelers with a brain of their own, an artificial intelligence system, is really a must for them to
So you think
function out there.
integration is most likely scenario in the long run?
Yeah, I mean, it's possible that we humans will not. I mean, we are the last generation that went to funerals. It's possible that within a decade or two, I was just talking about it with George Church, a geneticist, and he thinks that we might not die,
I
he and
saw
I.
that. Yeah.
Uh, and in that case, you can start to imagine augmenting the human body, allowing it to traverse great distances in interstellar space. Um, and maybe,
Yeah, and that's one of those big ideas as well, along with like free energy and other propulsion mechanisms that I think completely revolutionize how we look for other life and we look at our civilization. So, Avi Loeb, Harvard professor, thank you very much for talking to me today on Hard Truths Podcast. This has been an awesome conversation. Feel free to shout out where people can find you. I know you're not big on social media, but where can people find your content?
yeah, I write essays on medium.com. So if you just search for Avi Loeb at medium.com, you can subscribe for free. Every day or two, you will see a new essay that provides you with an update about space, astrophysics, all the Galileo project. And otherwise, there will be a Netflix documentary coming out this year, by the end of this year. And I know that it should be very exciting. They came with me to the Pacific Ocean and documented what we did there. And the reason I know it's exciting is because a member of, I heard from a girl in another country that wrote an email to me. She said, that was just a few weeks ago. She said, keep doing what you're doing. You have a huge amount of support from many of us, and don't surrender to any critics. Because I just watched the first 25 minutes of the documentary about your work, and I said, "Thank you so much," but I think you saw another film. It's not a documentary because it's only supposed to come out by the end of 2025. And she said, "Well, here is a photo of the television screen, and you're in day 5 of the expedition." And I'm actually a member of a club of Netflix that gives them feedback long before the
Yeah.
film is released. And so she got extremely excited, and that's why I think it would be a good one. And so that will come out. There are several other things that will come out that I cannot speak about. One thing that I can mention is that there is a sculptor, the most accomplished American sculptor. He was named America's Rodin, and he made two sculptures of Galileo Galilei in bronze, the size of a person, that he hopes to deliver to my office in the coming months, and then my office will turn into a small museum. I don't think I'll charge any fees, but I removed all the file cabinets from my office to give enough walk around space, and these should be beautiful
Well, I'll have to come by
sculptures.
when I'm next out there and come see the sculptures when they're completed. And I've read your blog, I guess it's a blog on Medium. I think it's great reading all that content that's out there. And thank you for the sneak peek as well. You have an ally in me and my supporters as well. Anybody that speaks out against consensus and willing to challenge preconceived notions is always somebody that I will support. So thank you very much, sir. Thank you for your time and have a great day.